In this video, I'm going to walk you through Lesson 4 of Unit B1. So we're going to navigate into the lesson by revisiting some of those questions that students asked when they were doing the gallery walk of those data posters from Lesson 3. So we have some questions about food and what drives the migration. And so we're going to first talk about what we figured out in our last lesson and those patterns that we saw using those wildebeest cards. And then we're going to talk about some questions that we have about how we can explore more about how food drives the wildebeest population. We're going to begin by watching a video interview, it's right here, with Dr. Sinclair. Now, Dr. Sinclair has been studying the Serengeti for his entire life, and he grew up in East Africa. He's written many books and papers about the Serengeti, and the video shares him talking about when he was studying the food sources of different species in the Serengeti, especially the wildebeest, and how they, instead of looking for food, they looked at rainfall, because rainfall can really have a direct correlation with the amount of grass that's grown, which is the food source for the wildebeest. So we watch the video and we discuss how his ideas can help us, and then we begin to investigate rainfall data. Here is a handout that students will use to look at some rainfall data. This is collected over a 30-year period from 1961 to 1990. And so it's average rainfall over those years. And you can see that there are some trends here. So there's more rainfall here in April. There's less rainfall here in July. You can see we've got a pattern here to our graph. And so we're introducing students to basically graphs and how to analyze data through a graph. We talk about what patterns we notice, and there's just a few questions as an introduction. We then watch a video to help us learn how to use an application called CodeApp. Now, CodeApp is used across many of the high school Open SciEd courses, and it's preloaded with data. And so if you click on data excursion number 1, and then you click view the simulation, it'll bring you to a pre-populated CodeApp file that has average rainfall for all the different months for 3 different areas. And so when they watch the video, they're going to learn how to create graphs for each of these areas to look at patterns in rainfall data. And so students are going to play with the data and they're going to create some graphs. And then we discuss the patterns in rainfall that could be used as evidence to support claims about the availability of grass. So this building understandings discussion is going to talk about what they noticed in their graphs, what patterns they noticed, and how this can help us answer some of the questions that we had. So students develop an investigation question and they're going to record it on a handout. There's a couple slides I will show you that helps them do this, but you can see the first part of the handout is about writing down the investigation question. Then they're going to make a prediction. Then they're going to figure out what is the answer to the investigation question when we look at another graph. So let me show you the slides that go with this. So first, we've got this slide to support in developing an investigation question about the relationship between the rain or the food and the wildebeest location. Then they're going to make a prediction, and the prediction is going to ask them to make a prediction for the month of April. So you can see the 3 different colors are the 3 different locations that where we have average monthly rainfall data to look at. So where will the wildebeest be in April? So we make our prediction, we write it on the handout, and then we connect it to the migration map to figure out if we were right or wrong. And so here's our migration map. And what we figure out is there's a wet season and a dry season. And so April is the rainiest month, and that is in the wet season. And so the dry season, you can see, is down here from June through November. So if you look at this, you can predict, you can see if the majority of those wildebeest, and this is by the red area here, are where they predicted. And so often students will suggest that they are in the rainiest area that's up at the north, but actually they're in the south. And so their predictions are generally wrong. It just depends on what they said. But most students will think that the wildebeest will be in the rainiest area with the most rain. And so they share their responses to the investigation question, and that is does not seem to be a relationship between where the rainfall and the wildebeest will be. The pattern of rainfall does not seem to help us predict where the wildebeest will be. And so we ask what we're able to figure out by looking at the rainfall, and we figure out they're in the south during the wet season and in the west and the north in the dry season. So after that discussion, we're going to ask them, what else do we need to figure this out? What additional data do we need? So this is kind of one big discussion. And so it says, what additional data do we need? And basically, with all of this information, we need to have more rainfall data. And we also need to know how many wildebeest are in these locations or when they are there. And so this takes us back to the CODAP, and we're going to look at a new set of data. And this one is going to introduce a new column to our data set. And so we will have a region, but this time we're going to have 3 rain gauges that we're averaging in the south, and 3 rain gauges in the west, and 3 rain gauges in the north. 5 rain gauges in the north. And then they have average rainfall. But this is a new column, the wildebeest percent occupancy. So this means 52% of the year the wildebeest will spend in this area. 26% of the time will be in the west, and 6% of the time during the year they will be in the north. So we're going to look at that data set. They're going to make some graphs, and then we're going to look for patterns again. So we're going to discuss the relationships in the graphs. And when we do this, we're going to introduce the terms of a positive relationship or a negative relationship with the graph. And so if it's going up, it's considered positive. It's going down, it's considered negative. However, if it's really kind of scattered, there's a general line of going up, but it's scattered. We're going to call this a weak positive relationship. If they're in a real direct line, we're going to call it a strong positive relationship. And then the same thing about negative. If they're scattered, it's a weak negative relationship. And if it's a straight line, it's a strong negative relationship. This actually comes up on the transfer task at the end of the lesson set. And so we're going to then answer question 7 on the handout, and then we are going to explore more about each region. There's a handout for students to take notes. It looks like this. They're going to take notes on the west and the north. They're going to answer questions about the advantages, what is limiting how many wildebeest can be there, and then why do the wildebeest leave when the region when they do. So what we're really developing here is the idea that there's a limit to the amount of grass that the wildebeest can eat. It's going to run out. And so we're developing the term limiting factor with this activity. And I want to point out that these are the regional data cards that students will use to complete that handout. These regional data cards are going to need to be printed out, and probably you need to adjust the format a little bit, but they're printed on 8.5 by 11. So you'll see there's always a little Google Docs formatting that needs to be done. Anyways, so you'll print these out, and this is where what they will use to take notes. And then we're going to finish lesson 4 with a consensus discussion. And this is going to look very familiar. And you're going to make a model with the map. And so notice the other stuff that we've put on. The arrows are still there. So you can carry over some things from the lesson 3 consensus model. But what we're adding now is information from the regional cards. And so we have food here. It's nutritious, and the grass brings wildebeest to the area in the wet season in the south. They're eating their grass, they're calving, and then they're going to begin to move up to the west when it starts to be a little bit more of the dry season. They can move around a little bit more easily because it's drier. And when they need to get more food, it's going to have a limiting factor. They're going to move up to the north where there's actually a little bit more water in rivers. And so even though it's the dry season, there's a water source. And so they come on up here. So we also are going to talk about predators. That definitely is going to decrease the amount of food that's eaten. But when you have a lot of wildebeest, because they just had a lot of babies be born, it's going to increase the amount of food that eats. And so we're starting to develop the idea of limiting factors and how much food is there for the wildebeest. So that's it for lesson 4. And we're going to talk about prep next, which is there's not a whole lot of prep for this lesson. All right.